This is the two problems from ray optics. See the first question. Let us see the first question. The angle of incidence for a ray of light at a refracting surface of the prism is 45 degree. That means the first angle of incidence is given for you. I1 is 45 degree. The angle of the prism A is 60 degree. It's an equilateral prism. The ray suffers minimum deviation through the prism. We shall know the deviation of the prism is I1 plus I2 minus A. At minimum deviation, when you say minimum deviation, I1 equal to I2. That implies deviation becomes 2I minus A. I is given as 45, A is given as 60. That is 90 minus 60, 30 degree. So the angle of minimum deviation is 30 degree. In both these cases it was given like 45, therefore these options are definitely wrong. I can definitely eliminate that two options basing on this data. Then further he is asking, what is the refractive index of the material of the prism? We can find the refractive index of the material of the prism using a formula mu equal to sin A plus d minimum by 2. This is possible, this can be used only when the prism is in minimum deviation position. As it is given that it is in minimum deviation position, I can use this. A is 60, minimum deviation is found as 30 by 2 by sin 60 by 2. Sin 90 by 2 is sin 45, that is 1 by root 2. Sin 60 by 2 is sin 30, that is 1 by 2. That is 2 by root 2, that is root 2. So refractive index of the prism is root 2. So this is 1 by root 2 is wrong. This option is right. That's how we have to solve this simple problem. Let us solve the other problem that is given for us. It was an AIPMT old problem. It says the refractive index of the prism is A. Refractive index for the material of the refracting angle, that means angle of the prism. Refracting angle is also called angle of prism, is A. Refractive index of the prism mu equal to cot A by 2. Then the angle of minimum deviation is how much? As I have used here, the formula is same for the refractive index of a prism under a minimum deviation condition. Sin of A plus d minimum by 2 by sin of A by 2. But mu is given as cot A by 2. That is sin of A plus d minimum by 2 by sin A by 2. But cot A by 2 can be written like cos A by 2 by sin A by 2 is sin of A plus d minimum by 2 by sin A by 2. This sin A by 2 and this sin A by 2 can be cancelled. So what is remaining is cos A by 2 equal to sin of A plus d minimum by 2. Now I can write this cos A by 2 as sin of pi by 2 minus A by 2. 90 minus theta, sin 90 minus theta is cos theta. Whenever there is a 90 or 270, sin becomes cos. Being 90 minus means its first quadrant, so it becomes cos. So cos theta can be written like sin 90 minus theta equal to sin of A plus d minimum by 2. We can take sin inverse on both sides, so it can be cancelled. So pi by 2 minus A by 2 equal to A plus d minimum by 2. So this is A by 2 plus d minimum by 2 equal to pi by 2 minus A by 2. That implies d minimum by 2 equal to pi by 2 minus A by 2. Take this to this side, minus A by 2. That is pi by 2 minus A. That is pi minus 2A by 2 equal to d minimum by 2. This 2 can be cancelled. So d minimum equal to pi minus 2A. Pi is nothing but 180. So 180 minus 2A is the answer for the problem. That's how we solve this problem. Thank you for watching.